Today, let's dive into the incredible world of atoms, the building blocks of everything around us. Why do we learn about atoms? At the end of this lesson, you will be able to identify the three main parts of an atom: protons, neutrons, and electrons, and understand their roles. Construct a hands on model of an atom using simple materials to visualize how protons and neutrons make up the nucleus and electrons orbit around. That's the concept of electron shells as energy levels, where electrons hang out and learn how they are organized. Recognize the concept of electron shells as distinct energy levels surrounding the nucleus. Understanding atomic structure is like having a superpower in science. It helps us build things, predict chemical reactions, harness energy, make medical discoveries, and create cool technology. It's the key to unlock the secrets of everything around us. So, we must learn about atoms. Atoms are tiny things that make up everything. Let's learn about them. The smallest particles of most of the substances are molecules. Molecules are formed by chemical combination of atoms. This is the molecule of water, which contains two atoms of hydrogen and one atom of oxygen. The smallest particle of an element taking part in chemical combination is an atom. The concept of atom is more than 2500 years old. Let's learn about atom composition. Atom is made up of two main parts. First part is the nucleus. The nucleus of an atom is its central core. The second part is the extranuclear part. The extranuclear part of an atom refers to the region outside the nucleus where electrons are located in their orbits. Nucleus. The nucleus is at the center of the atom and carries a positive charge. Almost all of the atom's mass is concentrated in the nucleus. The nucleus contains two types of subatomic particles called nucleons, protons and neutrons. Proton. Protons are positively charged particles found in the atomic nucleus. The positive charge in the nucleus comes from these protons. Each proton is represented by the symbol P and has a positive charge of plus 1 e. E stands for elementary charge, where 1 e is equal to 1.6 into 10 raised to minus 19 coulombs. The number of protons in the nucleus determines the atomic number of the element. Neutrons. Neutrons. Neutrons are electrically neutral particles found in the atomic nucleus. They do not carry a charge. The mass of a neutron is approximately 1 U, similar to the mass of a proton. Elements, except hydrogen, contain neutrons in their nuclei. The electron, tiny but powerful. The electron is a negatively charged subatomic particle denoted by E negative. Each electron carries a unit of negative charge. Electron properties. The mass of an electron is 1800 times less than that of a hydrogen atom. The mass of an electron is so small that it can be treated as negligible. Atomic number is how many protons an atom has. Atomic mass number is proton plus neutrons. Electron movement. Electrons in the extranuclear part move in discrete three-dimensional orbits around the nucleus. Instead of orbit, we use the term shell to describe these three-dimensional paths. Energy levels and shells. An electron's energy is determined by the shell it occupies. Shells are three-dimensional regions where electrons move around the nucleus. Electrical neutrality. The number of electrons in the extranuclear part is equal to the number of protons in the nucleus. This balance of charges makes the atom electrically neutral. Electrically neutral means what? Electrically neutral means that there is no net charge as the positive charges from protons is balanced by the negative charges from electrons. Electrons play a crucial role in the structure and electrical neutrality of atoms. Electrons contribute a lot in the stability of atom and formation of molecules. Understanding electron behavior helps us understand the fundamentals of matter. Atomic symbol basics. Understanding atomic symbols helps us decode vital information about an atom. Here C stands for carbon, 12 stands for its atomic mass number, C stands for its atomic number. With the help of this given information, we can find out neutrons of the particular atom. Here we have to deduct atomic number from the atomic mass number. Electron shells and energy levels. According to Bohr's atomic model, electrons move in stable shells. Each shell has a specific energy level. Electron shells and energy levels. The closest shell to the nucleus is this first shell, followed by the second shell and so on. The ordinal number means the position of a shell is represented by n and shells are denoted by symbols K, L, M, N corresponding to n is equal to 1, 2, 3, 4 and so on. In this figure you can see the K shell is the first shell, L is the second, M is the third and N is the fourth shell and so on. The maximum number of electrons a shell can have is given by the formula 2n square. As n increases, the energy of an electron in that shell increases. Here n stands for position of the shell. When the position of the shell is 1, it contains maximum 2 electrons. When the position of the shell is second, it contains maximum 8 electrons. When the position of the shell is third, it contains maximum 18 electrons, and when the position of the shell is fourth, it contains maximum 32 electrons. Electronic configuration magic. What is an electronic configuration? It is nothing but the arrangement of electrons in the atom. Electron shells labeled K, L, M, N have maximum capacities of 2, 8, 18, 32 electrons. Students can construct a such hands-on model to get the concept of the atomic structure. Teachers can construct such hands-on model to get the concept of the electronic configuration of elements.